Hello students, ever wondered that supposing you are moving in a car and another car, fast car, passes you further, what do you feel? You feel that the car is moving at a faster pace, and what does the person who is sitting in the other car feel? That you are moving in the backward direction. So what does that mean? That means that your motion, you are measuring it with respect to another motion. So that is what is meant by a relative motion. So when you are trying to measure whether your position, your velocity, your acceleration, your displacement with regard to any other object, that is, we say that there is a concept of relative motion. So relative motion can be applied into various parts. Let's see how it can be applied. As you can see, let's say A is one particle, B is another particle, and with respect to O, we are required to find it out, right? If I say the particle A is placed at a distance xa and the particle B is kept at a distance xb with respect to the origin. Therefore, xb by a, this is just one notation that we have used to represent the distance between the particle B and the particle A. So, for particles moving along the same line, so when we talk about the particles which are moving along the same line, as you can see they are moving along one straight line, time should be recorded from the same starting instant. So when both of them are going to start, and the displacements have to be measured from the origin. So displacements obviously have to be measured from one given point, right? So once we know that the given point is equal to this, as a result of this, we can say that this difference between x, that is the difference between the points B and A at any instant of time, is going to be given by the relative difference between the distances. Obviously you have to write down the distance of B with respect to A, so that is the distance of B relative to A, so that is the relative position. Or you can say xb, that is the position of the point particle B at any particular instant of time, is going to be equals to the sum of the distance of the particle A plus the distance between the two particles, so that is this. In a similar manner, we can say that the velocity of the particle B is going to be equals to the relative velocities between the two particles, or the velocity of the particle B can be given by VA plus VBA, and finally the acceleration as well. So all these things are relatively related. Now let's try to understand with regard to the case of a problem. So in this case, let's say you have a ball that is thrown vertically from a 12-meter level in an elevator shaft, let's say with an initial velocity of 18 meters per second. At the same instant, open platform elevator passes 5-meter level, so it is basically passing the 5-meter level upwards at a speed of 2 meters per second. Determine when and where the ball hits the elevator and relative velocity of ball and elevator at contact. So please try to understand one thing, that a ball has been thrown from the elevator shaft with an initial velocity of this much. In the same instant of time when the ball has been thrown, obviously the elevator also has moved upwards, so with a velocity of 2 meters per second. There is a difference in velocity, but after a certain instant of time, the ball is going to come down, so it's going to hit the elevator. So you need to find out how much has the elevator moved in during that particular time. So there are a couple of steps. The first thing is this, that you need to substitute the initial position and velocity and a constant acceleration of the ball with general equations. Then you are required to substitute the initial position and constant velocity into equation for uniform linear motion. Let's try to see. Finally, you are required to write down the equation of relative position of the ball with respect to elevator, and then you have to substitute the impact time to the equation. So let's try to see how it works. So if we do the same things that we just mentioned, we know that the velocity of the ball can be given by the initial velocity plus the acceleration. Because it is going against gravity, so there is a negative sign, as you can see. So 18 meters per second is the velocity of the ball only. We haven't found out the relative velocity. So here we are trying to find out the velocity and constant acceleration to the general equation. So once we do it, so we'll get 18, which is the velocity of the ball, minus 9.81, which is the acceleration, into the time taken. As a result, we can find out what is the displacement that is produced of the ball in the same instant of time. So that can be given by 12 plus 18t minus 4.905. So 12 is the height, that is the initial height with which it is being projected, so from where that is starting off, plus 18 meters per second, that is the initial speed, minus this, that is the acceleration. So if you do this, so what will you get as a result? So if you substitute the initial position and the constant velocity you'll get that for the elevator, you'll have the velocity of the elevator as 2 meter per second. So this is the constant velocity motion for the case of elevator, and the displacement that is produced of the elevator is going to be given by this. So if you just integrate this, because this can be written as dy over dt, so that will give you y or dy as equals to v dt. If you integrate this, that is going to give you this particular equation, right? So on substituting it, you will get in terms of the time t. Okay, using this, let's say if you solve it, so what you will get the difference between the velocity of the ball and the velocity of the elevator. So this is how the ball is moving, this is how the elevator is moving. So if you solve this, basically this is a quadratic equation, because you are required to find out the relative position of the ball with respect to elevator. So if that ball comes down to the elevator, again you are required to find out after what time the ball is going to come down. So obviously minus 0.39 second does not really make sense, because time cannot be negative as discussed before. So you are required to find out the time. So time will be equal to 3.65 seconds. Taking it further, what will we get? If we substitute the impact time into the equations, so what will we get? Because you already know the time, so by that time how much would be the position of the elevator? So if you know how much is the position of the elevator, so that is going to be given by this. So if you solve it out, so this is going to be 7.3 to 3.65 into 2, that's going to be 7.3 plus 5, so that is going to be 12.3. So 12.3 meters, so this is the height of the elevator. And the velocity of the ball with respect to the elevator, you can find it out, because you know this particular expression, you have to just subtract the 2. Plug in the value of t. 18 minus 2 will be 16. So 16 minus 9.81 times 3.65. So if you solve this out, obviously this is going to be of the order of 28 something. So if you solve this, obviously you need to solve this out. Once you solve this, so this is going to be the value of velocity of the ball with respect to the elevator. So this is how it works. Going to the next one, what we have, if you are given multiple pulleys here, right, there are different ways to solve it. Either you solve it using the concept of tension, you find out what all are the tensions. Then there is a concept of constraint motion. Here we will try to find out using the constraint motion. Let's see how it works. So position of a particle may depend on position of one or more of the other particles, because all these particles are connected together. This particle, all of them are connected together. As a result, what will we see? We will say that the position of the block B, in this case the position of the block B, what is the block B? This is my block B. It depends on the position of the block A, since the rope is a constant. So when the rope is of constant length, it follows that sum of the length, that is this here, if I just assume that this particular length and assuming this particular length is exactly the same, right? So what will we get? That's the reason you get xa plus twice of xb. That is going to be a constant, because starting from this very point, you will have this length as well. So xa comes only once. You have this length as xb, and similarly this length as xb. That's the reason you have xa plus twice of xb. In a similar way, what you can do, if you are given multiple, the 3 pulleys in this case, so you will have twice of xa. Twice of xa, why? Because you measure from here, Similarly, twice of xb, that is measured here, and xc is measured here, right? So that is the reason that is going to be a constant. So that is slightly ambiguous in saying that we are measuring xb from this particular point, we are measuring xa from this particular point, and so on. The reason being, we have to measure it from the center of the pulley, but we assume that these heights are negligible. These heights are very, very small. So these differences are negligible, and therefore we can take it this way, right? Hopefully this makes sense. So using this, because these are just constants, so you can differentiate these. So if you differentiate these, so they are going to give you the expressions of the velocity. So there is going to be one expression for velocity. If you differentiate this again, obviously at every instant of time, they will be moving under the influence of gravity, because their weights will be acting, under which they will be moving either up or down. There is going to be the acceleration as well. The velocity is going to be different. As a result, you can write down in terms of acceleration. So this is what will you get. Let's try to do a sample problem on that. So what we have here is the following. We have a pulley D is attached to a collar which is pulled down at 3 instants per second. So let's say this is your collar. At t equals to 0, collar A, so this is your collar A, starts moving down from k, so initial point is k, constant acceleration is 0 initial velocity. Okay, knowing that velocity of collar A is 12 inch per second as it passes L, so at this point its velocity is L. So acceleration is constant, mind you, down to the velocity. Determine the change in elevation, velocity and acceleration of the block B. Obviously when this is going to go down, right, it is going to pull this up. So when this pulls up, obviously there is going to be a change in the value of the, or if I say that D is fixed, right, so if I assume that D is fixed, so in that case what is going to happen, this has to rise up, because if this goes down, obviously the length of the string being constant, that is the case that has been taken here, length of the string being constant, the ball, the block B has to go up. Okay, so when the block A or the collar A comes down, the block B has to go up. Let's try to figure out what exactly happens. So you need to find out the origin at the upper horizontal surface. So if you understand that, starting from that very point, you will say that collar A has uniformly accelerated rectilinear motion. So you need to solve for acceleration and time t to reach the point L. Then the pulley D has uniform rectilinear motion. We need to calculate the change of position at the time t. Then block B's motion is dependent on the motion of the collar A and the pulley D. You need to write down the relationship and solve for the change of block B at time t. Finally, differentiate the motion relation twice to develop the equations for velocity and acceleration. Let's try to see how it works. Okay, you would have, why I'm doing this, because you generally would have done these kinds of problems using the tension concept. So I'm using a completely different concept to tell you how it works. So let's say at this, it's starting from here and it's ending up at this, you know how much is the velocity, therefore there is going to be some amount of acceleration. So if we define the origin at the upper horizontal surface, so at this point, let's say at any point here, the origin is going to be the starting point. Taking it further, you will say that the collar A has uniformly accelerated rectilinear motion. It's going to be going down under some acceleration. So we need to figure out how much is that. So for this, what we are going to do is that the final velocity of the collar A is going to be given by VA naught square plus twice of A XA minus XA naught. So this is how the velocity is going to be there. So if I solve this out, so what will we get? So we'll get 12 square. If I just put in all these values, so that gives me the value of acceleration to be equals to 9 inch per second square. I've just solved this because this is going to be starting with an initial velocity of 0, so this value is going to be 0. You know the velocity, initial velocity, you know its position, initial position, that is at 8. Solving that, it's going to give you the value of the acceleration. Now once you know how much is the acceleration, you can find out how much time it took to come to that point. So once you know how much is the time it took to come to that particular point, that is going to be given by this particular thing, that is 1.33 seconds. So this is the time it takes to come to that particular height. Now let's try to solve this. If you say that the pulley D is coming down, I told you about two cases. If you say that the pulley D is coming down, so in this case what is going to happen? The pulley D has uniform rectilinear motion. So how much is the position, or how is the position of the pulley D changing? This is going to be given by xd naught plus the velocity into the time taken. So let's substitute everything. So the difference is going to be equals to the velocity of the D, which is going to be 3 into 1.33 seconds. So that comes out to be 4 inches. Solving everything means writing down all the displacements. So you have the displacement of the pulley A, so that is XA. You have the displacement of the pulley B, that is XB. You have the displacement of the pulley D, that is XD. So putting it all together, you will say that displacement of D will be coming twice, displacement of A will come once, and displacement of the block B will only come once. So putting it all together gives us this. So this is the net value of displacement, which is going to be a constant. If you plug all these things, so this will have some initial value, this will have some initial value, this will have some initial value, right? So if you equate the two, that will give you the displacement, the change in displacement of the block B. So the change in displacement of the block B is known to us. So once we know about that, further we know that this particular displacement is a constant, because initial values are going to be a constant. So if we just differentiate this, the total value of velocity is going to be 0. So solving this will give us the velocity of the block P. So we know the displacement of the block P, we know the velocity of the block P. Solving all of it together is going to give us the value of the acceleration. Because this acceleration is known to us, therefore the velocity or the acceleration of the block B is going to be opposite to that. Sorry, it should have been A rather than V. This is AB. So AB is equals to minus 9 inch per second square. So this is the acceleration of the block B. So that way we understood as to how to find out all the things just by constraint equation. We haven't utilized all the free body diagram that is generally done to write down the equations, you write down the tensions, you write down the forces, you write down the accelerations. We haven't done that. We just used the concept of kinematics to solve it here. Hopefully that makes sense. Good. Now going further, if you have to write down the graphical solution of the rectilinear problems, so what all do we have? First one is this. So in this particular case, as you can see, this is the graph that is happening. In this case, the graph, the slope is here, this is the curve, this is the straight line. So let me explain to you what all do we have. So the first one, so when we talk about the rectilinear motion problems, first one is xt graph. So xt graph, if I say that it goes in a straight way, so the slope is this. So at any instant of time, if you are required to find out the velocity, so this is a non-linear graph with respect to the time, or with respect to the displacement versus time. So the slope at any instant of time is going to give you the value of velocity, right? Similarly, if you plot the velocity versus time, in that case the slope is going to give you the acceleration. The acceleration, if you plot with respect to time, in that case is going to be a straight line. So when we say it's a straight line, that means it's a uniformly accelerated rectilinear motion. Okay. In this case, the xt curve, the vt curve is equals to the xt curve slope, right? Then, given the vt curve, the at curve is equals to the vt curves. That is very much obvious. First one, if you are given any particular xt curve, you find out the slope. The slope of this is equals to this particular slope. And similarly, the acceleration at curve like this is equals to the slope. Basically, you are plotting the slopes, right? So these are the cases of uniformly accelerated motions, uniformly accelerated rectilinear motions. Then what we have, if you talk about the graphical solution of rectilinear problems, here if I plot acceleration versus time t like this, so here it's a negatively sloping acceleration, so that means it's decelerating. The velocity should also, so when it say acceleration is changing, so obviously the velocity is going to be non-linear. The velocity cannot be found out straight away. Why? Because acceleration is not a constant, so you cannot take out outside the integral, you have to integrate it. So given the value of given the function of acceleration, you have to integrate it over time, so that is going to be giving you the difference in velocities, right? So once you know about this, if you are required to find out the value of displacement or change in displacement, this is also going to be a non-linear curve, and therefore the change in displacement is going to be coming from the third graph. Hopefully it makes sense. Coming finally to this case, if you try to find out the moment area curve, so this helps you in finding out the position. So velocity time graph, so from here if you find out the area, so the area is going to give you the displacement, how the displacement varies with time t. So x minus x naught you can find out as v naught into t1 plus the difference in the time intervals over a particular amount of velocity. So here we are not doing anything, we're just trying to find out the area under this graph, right? So if we use dv equals to a into dt, so this simplifies to this point. So provided you are given the expression of acceleration, you can find out how the displacement is going to vary with time, right? Hopefully this was clear. So students, we understood about what are the different types of relative motion. Where all do we have the relative motion? Relative motion is actually a concept that is applied everywhere. Even when you are moving from some point to the other, you are obviously taking your reference point. Let's say the starting point can be a reference point. Any other thing that you see around you is actually a reference point. So every time you will actually be using a relative motion concept. But we do not really apply that because those reference points are nearly static. Many a times your reference points may be moving. That is, your reference point can be with some object that is also moving with respect to you. So with respect to that object, you might either be at rest or maybe moving uniformly or maybe accelerating even. So those are the concepts of relative motion that help us. So this relative motion concept and the other concepts that we have so far learned can be elaborated further to the case of a non-linear motion. So that is going to be a curvilinear motion. So that's going to be a very, very interesting concept. Please be tuned in.